Next lesson, parallel and perpendicular lines. I know you know the definitions of those two, but it gets a little bit tricky when I start to ask you, create a parallel line equation that has to run through a certain point. So let's go ahead and try some of the basics first, and then we'll get a little bit more expert analysis on it. Parallel lines are two or more lines that always are equidistant from each other and never intersect. Equidistant, equilateral triangles, it just means that they have the same distance in between forever. So for instance, on a graph, parallel lines always have the same, yes, hopefully you said it, slope. Okay, they always have the same slope. So let's try example 1 here. Y equals 4x minus 9. I want you to create a line that's parallel to that. Really simple. I know the slope is 4. It just has to have the same slope. It doesn't matter where the line starts on the graph. It can be any number. So we can make this y equals 4x, and we can really just leave it like that because that's y equals 4x plus 0. But let's just make it interesting. Plus 1,000. Who cares? That is a line that's parallel to this line. Now, you might not be able to see it because that's a significant difference, but you get the idea. Has to be the same slope. Now, what if I said to you that I wanted you to find an equation of a line that's parallel to this that runs through the point 1, 2. Now that's a lot different of a story. Now I'm going to make a really small graph here and it's going to be really ugly, but I hope you get the idea to it. So minus 9, let's just say it starts down here. Slope is 4, up 4 over 1. 1, 2, 3, 4 over 1. So let's say that this is my line or something like towards it. If the parallel line has to run through the point 1, 2, it means that the other line, it has to have the same slope, so it has to have the same steepness or angle, and that's a terrible line, by the way. It has to run through that point, though. So we have to incorporate point-slope formula in order to find the equation of this top line, which I wouldn't even classify as a line, really. It's just kind of total garbage. So to do that, we need to incorporate another formula, which is point-slope. So point-slope formula is y minus y1, which equals m, which is the slope, times the quantity x minus x1. So point slope formula is aptly named. If you have a point and you have the slope, you can find the equation of the line. We do have that. We have the slope and we have a point. So you don't really have to label those points because you know that that's an xy pair, but just go ahead anyway, kind of for brownie points or whatever. Kind of wish I had a brownie right now actually. So y minus 2 equals the slope, which is 4, x minus 1. Solve this equation out. So y minus 2 equals 4x minus 4. Add 2 on both sides. Y is going to equal 4x minus 2. So this is the equation of the line that's parallel to this one and runs through that slope. So for instance, if the point is 1, 2, let's make a table of values here just to make sure we are on the same page. So if there is a 1x and a 2y, let's go back one. If I know the slope is 4, that means the y value is going to go up by 4 every time I increase x by 1. But what happens when I decrease x by 1? It means that the y value has to subtract 4, has to go down 4 units. So if I subtract 4 from 2, I get negative 2. Now let's look at our equation that we just built, and hopefully you can see that. I actually don't think you can. So if you see that there, the y-intercept is negative 2. Exactly what my, that's a good point right there. Exactly what my table of values says it is. So if I were to actually plug in 0, negative 2 to that equation, 4 times 0 is 0, and y equals minus 2. Exactly what we have. That right there proves that this is the equation to the line parallel to the first one we had that runs through the point 1, 2.